Okay, recording is started. Hello. Actually, sorry. I think it's been 1 month. I think video upload చేయక. So yeah, I'm sorry for that. ఇక్కడ నుంచి continuous గా I'll try to upload as many as in crafts, and yeah, after that let's get started into functions. But I said too many times this time also. Like if you are preparing for JEE or MSET, try to understand more about plots. That will help. I think recording started. Yeah, it started as well. Cool. Yeah. No, so this is like part two of the previous lecture. I'll mention it as a YouTube title. That is piecewise defined functions part two. Okay. And yeah. Okay. So if you didn't watch previous lecture, I'll recommend you to watch it. If you're like, you can directly come here without watching previous lecture if you have a basic understanding of what is previous, like piecewise defined functions and modulus, what is like modulus will do to the function. That is enough for this class. Let's call this class lecture as absolute transform, simply modulus transform. I'm like sorry for this lecture. Maybe this in this lecture the handwriting might be wrong. No bad because I forget the tab actually. I'll try to do less handwork and more on the plots. So yeah, forgive me on this. Cool. Mm, okay. Uh, in this, we'll discuss 6 transformations that absolute transformations. First is f of x transform to. So let me zoom it. It'll be good. Better. Okay. Mod f of x. ఇది ఆల్రెడీ లాస్ట్ క్లాస్ లో నేను చెప్పాను. If you didn't see it, better see the previous lecture and see how it is. And second one, okay, I'll give here only then. Second one, f of x transform to f of mod x. Third one, f of x transform to mod f of mod x. These are advanced transformations actually, but which are pretty easy if you follow this lecture. Okay, cool. Let's say y equals to f of x function ఉంది అని అనుకుందాం. I'm sorry, like this lecture will be like too much slow, but yeah, I'm sorry for that. Okay, cool. F of x, y, y equals to f of x transformed into same like mod y equals to mod f of okay, step for mod. Let's call mod f of mod x. And sixth one, mod y equals to okay. Like sorry, that equals to f of x transferred into mod y. Okay, sorry. That's what, like these are all some unnecessary things. I'm sorry. Okay, mod f of mod x. Okay, the C transformation we'll discuss. Okay, let's go. Let's jump in, right? Let me take my piecewise defined function. Let's define it as like this. Insert some equation. Let's say f of x is there equals to okay, yeah. Let's take f of x equals to -3 if No, 0, sorry, minus 3 less than or equals to x less than 0 x if 0 less than or equals to x less than or equals to 6 and 3 if like this is the simplest possible absolute sorry piecewise function I'm taking. You can take anything, but I'm gonna apply every transformation to this so you can understand easily. You can, it's like you can make a short notes or whatever easily. That's why I'm taking this function. There is no specific meaning why I'm taking. You can take any function if you start with, but I found this function is interesting. That's why I took. Okay, cool. Okay, fine. Okay, now this is the function and let me plot it. Okay. Let's call this function is there. Let's take some random lines. It's not random actually. So can you guess the point? True. So this will be minus 3 comma 0. So at this from minus 3 to 0, it's just constant, just a value of you can say minus 3 comma 0 is here. Okay, cool. Line. So from here it's just x. So this is okay. I'm sorry about slowness of this. I'm really sorry. So 6 comma 0. Okay, so here it is. So between here it's 6 comma 9. It is again 3. So this will become 9 comma 0. So this is how the typical plot look like. So it's indirectly this is equivalent if you draw in plot like let's say f of x. What's this x? Okay, let me copy this actually. This will help a lot. Cap. Okay. Okay, sorry. Okay, yeah, so that's the plot. Let's start with first transform, that is f of x transforms to mod f of x. Okay, so same actually. If you see here, I think last class one explained this. I know it's like then f of x less than 0, like wherever if you are seeing f of x less than 0, just make it positive. That's that simple. So let's call this gap. Let's zoom it a bit, maybe helpful. Yeah, cool. So any guesses how it will look like? Yeah, I think they're guessing correct, maybe. Let's see. So this portion, if you see here, this is where f of x less than 0, like this guy is becoming less than 0, like negative in this f of x. So these two portions is negative, so we have to make it positive, means shift it upwards and like this. Yeah, you're guessing correct. Okay. And, oh, related. I think there is an option actually if you double click on it, but I don't know why it's not staying. Cool. And that's it. And this is how f of x, mod f of x is transferred to mod f of x look like for this function here. So that's it. Think if you have any doubt on this, like see in previous lecture, I can ask me in comment box because this is pretty basic. Okay. And yeah. Let me come to second one. Oh, okay. F of x transfer to f of mod x. This is interesting actually. If you observe clearly, let's call this guy up. Okay. Okay, let me take a pen. I'll take a basic function. Let's take a plot of simple function f of x equals to x plus 3. So can you know right? Y-intercept is 3 and slope is 1 and x-intercept is minus a naught by a1, so it is minus 3 by 1 and directly minus 3, so it's 1. Okay, cool. Simple. So f of mod x, what will become? It will become mod x plus 3. Cool. This is f of mod x. Okay, and next. Oh my god. Okay. I'm sorry, guys. Yeah. This is x plus 3. This is minus x plus 3 because making it as x less than 0. So this is where x greater than 0, right? This portion. So this will stay same, but this is minus x plus 3. If you take, let's take x equals to, we have to take x less than 0 values. So x equals to minus 1, then what will become? Minus of minus 1 plus 3. So it will become 4. Same like x equals to minus 2. Yeah, if you calculate it, you will come with 5. So indirectly, if you see the values are shifting here, it's 4, 5. So the plot is this one. So what is the key takeaway from here is whenever x less than whatever x less than 0 values are there, not f of x less than 0, I'm saying x less than 0, just ignore it. Okay. And this is a basic mistake actually. If you are thinking, let's say, you can take two, like you can do it for two things. Maybe you can try a straight line or not, like reflect about this axis. But this is hectic for some plots like that. There are some like complex plots where you'll get easily like to say confused. So I'll refer is like this function is there. just delete it, whatever is there. Just delete from your mind. Now nothing is there. And whatever this function is there, just try to reflect about this y-axis. That's it, simple. So this, that's it. Okay, cool. Let's try to write. So this is x less than 0, right? So this one, this portion. So this just delete it. Okay. I'm saying people may delete this one because this is f of x less than 0. No, a big no. That's what like it will make confused. And again, see if you are taking like this, and if you are plotting like this, let's say, then this is wrong because see if you are taking this as something, and if you are reflecting about this axis, and if you show here, this is not, this is wrong, right? There is concept actually. There is a continuous and discontinuous function. Simple. Continuous means there is a function, it will go like this. Discontinuous means there is a function, it will go and it will skip here and it will go like this, whatever. So this is discontinuous. So this is continuous. C, DC, and here we are dealing with no, like if you see flow -3 to 0, 0 to 6, 6 to 9. So whatever transform we are making to continuous function, the transform itself will remain as continuous. So if you do like this is wrong. Okay, cool. So that's why I'm saying like to make it as continuous, what you have to do is like simple actually. Ignore whenever the x values are 0 and just try to reflect about that y-axis. Cool. Let me erase this one. Okay, cool. Take a line. That's it. Will come. Erase this one also. Okay. This will come here. Okay, I delete it. Okay. Oh my god. Come on, dude. Yeah. Okay. So it's like whatever this portion is there, we reflected this portion. That's it. So how it will look like? Simple words. This is what it will make to f of mod x. So that's it. Cool, right? I hope you get it easily. Yeah. Let's go to next transform. That is f of x transform to mod f of mod x. Okay. So this is a function. It's actually simple. Actually, you have to make how can I say? You can take the help of previous because directly f of x equals to mod f of x means what I have to do is like first transform f of x to mod f of x and then from that function to mod f of mod x. Simple. I'll show you how it is. Okay. Oh, let's minimize somewhat. Now it's looking good. Okay, so this is f of x. So first one, transform to f of x to mod f of x. Okay, so let's transform this to mod f of x. Let's take this as mod f of x versus x. Cool. So the line. Let me turn the color blue, maybe. Yeah. So simple, like these things, we ignore it. How to become? Yeah. So I have to mirror image of this on that side. That's it, simple. There is an option. Okay, sorry. Okay, whatever. Yeah, I think this should look like this. So this is how mod f of x versus x looks like if you see from here. Cool. Next transform is simple. Let's transform to this function, mod f of x to mod f of mod x. So directly let's copy this function. Okay, now so this will become mod f of mod x versus x. So again, like whenever x less than 0, ignore it. That is, this is here x less than 0, right? Just delete it. Okay, and mirror image of this. Yeah, I think you're guessing right. So see, this one. Oh, okay. Delete it. I'm sorry. So it will come here, right? Exactly at this point. And yeah, I think there is some mismatch. Like this is too much near, but this will be symmetric only. Okay, that's why maybe I draw like that. Yeah, actually, if you see here, there is some mismatch here. I think 3 comma 0 will come here, like so it will come like this maybe. So whatever. Directly the function rest up. It will look like this about this axis. So yeah, this is how mod f of mod x now will takes place to different functions. So first you define like first you have to transform to f of x to mod f of x, and from there f of mod f of x to mod f of mod x. Okay, cool. Yeah, let's go to next transformation. I hope you're getting it. It's like if you observe clearly, you can draw this everything in less than 3-4 minutes. I'm making it as derivative like simply for first time, guys. Okay, cool. Now equals to f of x transforms to mod y equals to f of x. Very simple concept actually. Let's take a function like y equals to f of x. Okay, let's take plus f of x. Okay, let's take mod y equals to f of x only. How it will be like? Let's call a function f of x. So that implies mod of f of x plus f of x. Okay, let's call it plus f of x equals to mod of plus f of x is f of x, right? Simple. Let's take minus f of x. That implies mod of, I think if you take negative also, it will you can make it positive, right? That is of absoluteness. So that is also become plus f of x. So what you're taking here is key thing is when even if f of x is plus f of x, or even if it is f of x equals to minus f of x, both times same. Both times you're getting the same value. Indirectly, mod of y equals to f of x. Indirectly, that means y equals to okay, let me give this an equation to look cool. So directly y equals to okay, 3 plus or minus f of x. Directly, even if y equals to plus f of x or minus f of x, it doesn't matter. If you doing mod y equals to f of x, both values will become 0. That means, uh, okay, mod y equals to f of x. I think there will be some symbol here. So equivalent to this one. So okay, so indirectly what we're calling it, both are having same name. That's simple. Cool. Let's take a plot. Okay, let's first paste it. Oh no, okay. I'll try to copy this one. Okay, this is a function. So how mod y equals to f of x will look like here. Before that, let me take like this if plot. Let's take a function y equals to x plus 3. So okay, I'll do one thing. It's just disturbing. Let's go to plots. There is a traffic calculator actually. Last time I told you about GeoGebra, right? This time we'll see Desmos. Desmos is more cooler than GeoGebra actually. Okay. Okay. So let's go here. So let it come. I think my internet is slow. So what I'm trying to do is like simple. I'll show here only. Okay. Let it open. So yeah. So meanwhile, let it open. So So what we have discussed previously is like linear functions, quadratic cubic functions, and piecewise defined functions. There are other things also, least integer and greatest integer floor and no flow functions and all that we'll deal with next class, maybe after 3-4 days because my pad need to come. So before that, yeah. So this is how lecture goes like this. Let's see. Like there are too many topics in graphs that I'll add. Maybe become 20 lecture series. I think. Let's see. Okay, whatever. X plus 3 is there, right? Cool. This is how x plus 3. This is minus 3 and this is 3. Cool. Take this 3 gamma 0. And if you take this is minus 3 gamma 0 is minus 3 and 3. Okay. What I'm exactly trying to say is like so this is plus f of x indirectly, right? So minus f of x means minus of x plus 3. See? So, but see again, I'll show here. Let's say y equals to x plus 3. And so this is how mod y look like. So let's drop it. So this is how mod y equals to x plus 3 looks like. Now, if you go here, what I'm trying to explain you is simple. Okay, let's take it directly this one. Let's take a plot. So So this is x plus 3. Okay. So this is x plus 3 looks like. Okay. Cool. So this is a directly plus x plus 3. So how minus x minus 3 will looks like? Just now I shown it. Like, yeah. It's like f of x is transformed to minus f of x if you remember last lecture. So somewhat it will look like this. Okay. Minus x minus 3. Now this is y equals to f of x versus x. Okay, so if f of x equals to x plus 3, then this one, and f of x equals to minus x minus 3, and it will come this one. Okay, okay, cool. But what about if you're doing mod y equals to f of x? So take a break here and just try to think what is the y-axis and x-axis for a mod y equals to f of x looks like. In simple words, what you're trying to do, like, is it maybe is it you're drawing between mod f of x versus x? No, mod y versus x. Yeah, so no, what you're trying to do, you should remember actually. Okay. Take it. I mean, I'll explain, but you just pause the video and just think about it. Okay, cool. Let's see what exactly we are. Like let's say what is y-axis and what is x-axis here. Okay, so this is mod y. It's very simple. This is mod y only, and this is x only. But again, don't get confused because if you are taking mod y and let's take y equals to f of x, and now we are transferring to mod y equals to f of x. Yeah, cool. So in this will do. Okay. Yeah. But see here. Still, it is y versus x only. I'll explain you why. Let's take a pen here. So this is y equals to f of x versus x, right? Cool. See, let's take a plot y equals to f of x. That means plus. Okay, that means whatever is like, let's say a function is there. So it's defined like this. So let's say this is, yeah, let's say like this. Let's say this is f of x less than 0 right here. So just ignore it. What we take is like we need this portion only. We need a portion of just plus f of x, not f of x when it is negative. Cool, right? Let's try to get into mind. This may take time. Even for me also, initially when I'm practicing in class 1, it took me some time. But it's very, very small concepts required actually if you think in the same direction. I'll repeat it in last time. Yeah, same. Let's take this is like my f of x. We need minus f of x only from this. Not when f of x is less than 0, so just ignore it. So this is minus f of x. I'm saying again, but clear purpose. Let's take, so this is how it's looking like, right? Let's say this is f of x plot and this is minus f of x plot. What I'm saying is simple. We are dealing with y comma x only, but let's say this is plus f of x, right? There is no point if f of x is becoming negative in this. Okay, I'm saying when you are plotting for mod y equals to f of x only. Okay, and same. So this should be negative only. There is no point and it is negative positive. So delete this one, delete this one, and this is how original plot looks like. Now if you try to plot it, I hope I clear it. If you have, like, those guys, if you're having any doubt, can think in a direction. Like, if you are those guys who got it, just skip it. If you those guys, if you get it, didn't get, think in a direction. Uh, let's say, okay, random function is there. Let's say this is f of x, and let's call this as some minus f of x. Okay, okay. This should be always positive. So what's the point of it if you're taking this one also? That's why we are removing this, and we should be always negative. What's the point if you're taking negative also? So this is how mod f of x versus x, sorry, mod y equals to f of x looks like. Even it looks simple, sometimes it will distract you, because if you take f of x, simple f of x comma x, if you plot it, we'll take whole, right? We won't say just like ignore this one because we are taking plotting between plus f of x versus x. Epic, no, because we are conserving both plus or minus f of x versus x. Okay, it's not a simple f of x versus x. Okay. Yeah, so as we discussed, we are considering plus of f of x minus whatever of x minus x. Okay, I think it's too much to discuss, but what it, yeah. Okay, so I hope you get it. Okay, so, so without wasting, let's apply. Okay, let's take a function is here. Say, so let's apply transformation. So transformation we applied is mod y equals to f of x. So what this will do to a function? Let's see. Don't know. Like, I mean, yeah. Like, let's see what it can do. Okay. Cool, right? Okay. Wow. Remember previous concept. So this is how f of x typically looks like. Okay. There is a small concept actually. If you see here, that is, yeah. If you see here, what is happening is like x plus 3 is like this, right? Top one. And let's say you plotted x plus 3 like this. Just making you understand how it will look like actually. So this is x plus 3, and this is x plus 3, whole x plus 3 looks like. And we are ignoring this, which is like f of x less than 0, and make it reflect like this. That's it, simple actually. If you do like this also, like if you can, I'm directly getting final result, but you can do like this. Say x plus 3, x minus 3, and ignore this one, directly you're doing this one. It's like I'm saying, four transformations, we are making it a single one. So logic is simple. If you draw a function, neglect it, reflect it. That's it. So, so this is less than zero. So f of x less than zero, neglect it. Draw a line. Okay, cool. Or we don't do like this. Delete it. Okay. Most of the experiments, I think it's better to keep it silent. Yeah. I mean, experiments in drag because length of the video will extend. Okay. Yeah. Cool. This is how it looks like actually. Same function. Like this. Like this. So simple, right? So this is how like when you apply mod y equals to f of x typically looks like. Okay, let's have a next transformation. Let me see it's recording code. Okay, let's have a next transformation. Y equals to f of x. Transfer to can say mod y equals to mod f of x. Okay, cool. Let me copy this guy. Okay. Oh, nice. Yeah. So same like first transformation here is first we have to transform mod f of x versus x. So copy this guy here. I think there is some shortcut D. Okay. So let's remove this guy. So this is how mod f of x versus x looks like, right? Now apply transform mod y equals to mod f of x. Okay. So if you remember mod y, if there is something less than 0, ignore it. With here, sadly, it's already ignored. Yeah, and reflected about x-axis. So, okay, I might erase this one. It look better. So now we are with this function. Like this, we are having like this function, right? Now just reflect it over here. So that's how it will look like. Okay. Yeah, that's it. See why I reflected it because if you go here, when we're doing more by stuff of x, let's say we are ignoring this one and we are reflecting by this, right? Let's say initial function itself is like this. So even if it is there or not there, there is no issue. We have a trans to reflect it. Let's say have a function like this, and if I apply mod y equals to f of x transformation, so we have to reflect like this. So both are having same. Understand? Actually, there are some questions actually. Maybe I'll discuss it last because there are some JEE problems that they will play with like this. Let's say what they will do is like say separate plots they will give. When they are in equations only, here I'm saying in plots, and they will give two functions. Okay, and for same they will give like in this function, let's say 1, 2. So here the transformation that is mod y equals to f of x. So here what we did, same like this is f of mod x, right? Equivalent to mod, let's say f1 of x, mod y equals to f2 of x. So these are both are same, similar meaning, because if you do like this, you will end up with same. We will come up like these questions. See, when you solve that J problems, you may understand and better. Okay, cool. So this is how. Let's go to sixth transformation. Let's go quickly. Uh, y equals to f of x. Transfer to. Let me give me a minute. Okay. Mod y equals to f of mod x. Simple and easy. Let's see. This is the function. I'll try everything in same plot now. F of mod x means x less than 0. Ignore this one. So somewhere it will look like this. Okay. And just ignore the points. So this is both the same. And now we have to apply modulus. So ignore negative f of x. Transfer like this. So this is how it will look like for the function. No. It is equivalent to now like this. Something interesting. Shape. Similar shape. Maybe some rocket can say. Okay. Next transformation 7. Y equals to f of x transfer to mod y equals to mod f of mod x. And let's get up this guy. Control C. Control V. Okay. So first let's transfer this to mod f of x. So we can ignore this guy. And now f of mod x. So that it's x less than 0. Just ignore it. Now transfer it around y axis. Okay, cool. Now there is nothing down, but we can have to plug modulus. Have to transfer like this. Okay, so somehow it will look like this. I'm sorry about the diagrams, but you can try well in your notes. So this is how it will look like. So this is how you can play with absolute transforms. And yeah, let me give you one homework question. Let's take a function f of x, something the plot looking like this, Let's say minus 3 comma 0. Let's call this x square. Let's call this x. So it's plus 3 comma 0 minus 3 comma 0. Let's call like something minus 3 constant line. Yeah, that's enough. For this, apply all 7 transforms and upshow. Okay, cool. Let me show in Desmos. Okay, cool. Actually, I took this function actually. Now, like, let's say in Desmos, f of x equals to, let's say, f of a x. Okay, add a slider and you can observe like how f of x will change if you add, like how it will happen. Now, same like stake first transformation, that is mod. So mod f of x. I think you might know, right? This one will ignore, or like this one will become positive, so it will come up. Let's see how it will look like. Say nice. Let's say mod f of, okay, f of mod x. So same like this one we have to ignore it and transfer this one to here. Same like mod f of mod x. Oh no. So this is how it will look like for that. Can do like this also, like mod y equals to f of x. How typically it will look like. You can observe those and play with it. It is interesting. There is more things you can explore here. This is like Desmos art contest. If you come here, there are some uh, they are designing astronauts, some more stuff using math. I mean, like if you have interest, take a problem not this much complex. Take something like this much is simple actually. Maybe it's finalist, okay, maybe tough. Yeah, like take something simple one. Let's take try to draw, no, uh, draw this flower, butterfly in Desmos. That will be interesting, and if you watch it, like if you try it, yeah. Anyway, that it will come to end of the lecture. If you have any doubts, ping me in the comment box. Maybe we'll see in the next class with least integer function and all. Yeah. So have a good day and happy Makar Sankranti to everyone. Have a good day. Bye.